Okay, thank you. Good morning, everyone. Okay, so I will explain, what's going on in S-33 and what we are looking for as a management and protocol layers. Layer in between, all the kind of nice things happen, and then, capable of physical layers. So we need to make them, to fit together in the middle layers. Okay. Okay, so just explain, where we are, what we are working on. So the physical layer is, it's done by 32, and then, application and presentation almost like codecs and applications, widgets, HTML5, those kind of done by S-34. So we need to make sure that, they come to our kind of pipeline and then delivered to the physical layer safely, and then it can be kind of managed as, expected. Okay. To give us some little bit of understanding why we are kind of going some directions in ATS 3.0, I want to give you some kind of history, a little bit of that where you're actually coming from. So the system we are currently using today, as in ATS 1.0, it is I don't say it's kind of an implementation or user point of view is kind of simple thing, but I can from the standard point of view is rather simple than what we are doing, because it's all based on impactor system. So it handles kind of multiplexing and clock reference and AV synchronization, and then all the kind of signaling information as well. So everything is done by impactor TS. So it's kind of take it and then do a lot of kind of a little bit of modification, and then it's done. That was kind of reference point, what we have done in ATS 1.0 as a kind of management and protocol side. And in between 3.0 today, we are developing, and in 1.0 we are using today. There was a lot of activities regarding ATS 2.0. It's not a single standard; it's kind of multiple part of standard. And what ATSC has been looking for as a ATS 2.0 is kind of adding IP or broadband stuff on top of ATS 1.0 without kind of dramatically changing 1.0. People consider how to actually add those features or make a connection from OTA signal with that features. So we went to kind of interactivity, personalization, and the measurement stuff, and also we consider kind of NRT, and then consider some other interface, like storage or the kind of other things. And then also kind of after ATS 1.0, there has been a lot of development in the codecs area. So ATS 2.0 also tried to introduce new type of codecs like ABC. After that, ATSC has been developed MDTV, mobile TV, MH, somehow known as. So I think what you can see from the previous thing, the major changes, using IP as a kind of the delivery protocol. So it's kind of using ATSC on top of AVSP, and then use most of ITF protocols for the delivery and management. So that's kind of lead us to kind of work on somehow considering not only broadcast, but also considering kind of bidirectional, interfaces. So, what we are working on is kind of how to deliver content, not only using physical layer, which Luke has just kind of, explained, but also using, public internet as another type of delivery. That's kind of, reflected in our scope of work of S-33. That's a key point. Okay, so to achieve that goal, and S-33 has been kind of has established three separate ad hoc groups, and then you can see here that what kind of actual technology or key components is developed by which ad hoc groups. The first one is service delivery and synchronization. So that ad hoc group is chaired by Richie Chunuk. It's kind of a little bit of strange, situation. TG3 chair also working for ad hoc group chair. So I'm in between Rich, actually, literally. Okay. Also chaired by Charles Roy. Since it is kind of heavy work, they have a conference call every week. So it's kind of a little bit kind of very intensive work. So it's mainly mainly working on delivery and synchronization, and then signaling, error recovery, and emergency alert. Okay, and you can see that actually the kind of core part of delivery is done by 33-1, and then you will hear more about the detailed progress in the afternoon. 33-2, service announcement and personalization. That's more about the ESG stuff. And also one other important thing in here is in UCG reporting. So how we can get back the kind of how much time user has been watching what kind of a data program. And 33-3 is working on interactive service and companion screen. So it's chaired by Madeline. And then you can hear more about progress there. And then it's also working on kind of second screen interactivity and redistribution support app signaling. So I think mostly one or two components from this diagram could result a part of standard. So we are working on kind of structure of the standard possible outcome delivery of S-33. We are trying to not to put so many things in the same standard, so to make hard to manage, and people have some hard time to find where exactly the piece I'm looking for. So potentially one or two components from this would result as a separate part. Okay, so for a kind of little bit of standard, little bit of kind of the matter how to organize. So you can hear more about the program in detail. Even though I will provide a little bit of background. 33-1 and 33-3 related activities this afternoon, and then 33-2 activities will be covered at the end of my presentation part by Sachin. Okay, so a little bit of background of what you're doing as a management layer. Kind of bottom line is using IP. So as I mentioned, ATSC MDTV was the kind of standard using based on IP, and then we have decided to fully utilize IP as a kind of a single delivery protocol in 3.0. So we can really be a kind of IP-friendly broadcast system. And also we are considering a lot of other well-known, widely used and verified technology, which is also kind of futuristic as well, and also use some of components widely used by the industry without complicating it. For example, I think UTC-based or wall clock-based synchronization is one thing. We are kind of dramatically living from STC like local clock-based synchronization, so it can give a lot of kind of new features to the broadcaster systems. And watermark is one of the key technology. You will hear more about that. How to really kind of overcome or bypass all the intermediaries if it's required. So I want to give a little bit more kind of information about what we have kind of chosen as a kind of little bit of important building blocks. As I mentioned, IP-based protocol will be used as a building block, and then I just mentioned that UTC wall clock-based time is another important change from our previous standard. Another important thing is ISO BMFF. It's a file, but we decide to use that file structure as a streaming kind of format. So it's not only used for kind of download or local storage format, but it will be a kind of base for streaming format. So that somehow kind of laid us kind of the challenges or potential problems we need to think about. So ISO-based file format is good to provide all the basic lip sync features and component based synchronization, all the relationship together. But that's not really kind of format you can just send it bit by bit, and then players can continuously playback as of the professional service of today. So there might be somehow kind of some work needs to be done to a little bit convert that file. The word we are using is encapsulation. So how to encapsulate that file format which is kind of streamable. So then we can also we can deliver that as a streamed data. And then also we need to think about what's the right application layer protocol which can deliver to the client with we're providing all the kind of buffer models and all the error correction features. So those are kind of key things for the delivery aspect we are working on. Yep. So this is kind of very kind of a simplified version of highlighting the major decisions we have made on those to solve those problem. So two encapsulation file format, deliverable format, we have chosen two different format, MPEG dash and then MPU format. And then they will be kind of delivered by two different protocols, MPEG media transport protocol and also route. So and then for the broadband side, we have decided to use only consider only HTTP. So this is most widely used, and it's kind of I think there's no alternative really kind of just in today's market. So you will hear more about what's the details of this protocol stack and actually what actually all the cryptic acronym means this afternoon. So then now it's time to give a floor to a little bit time for Sachin to explain a little bit more about the ESG part, and I will come back after that.
Thanks, Young. My name is Sachin Deshpande, and I will talk about S-33-2, which is a group on service announcement and personalization. So the service announcement data model is based on OMA BCast 1.0.1, and we also took some elements from the BCast 1.1. And then we further did some more extensions of that BCast model in ATSC 3.0. And those extensions include speech phonetic information extensions for service description, service level extensions for channel icon and channel numbers, and content level extensions which include both component description and device capabilities descriptions. So this is one snapshot of how the service announcement fragments are organized. So the main fragments include service fragment, schedule fragment, and content fragment. And the service fragment basically describes the overall service. The schedule fragment provides information regarding when it's that service scheduled. And the content fragment describes individual programs and content in the service. So the encapsulation of the service announcement data for delivery is also based on OMA BCast 1.0.1, and we added some constraints on it to fit the ATSC 3.0 model. And it is delivered as service guide XML fragments, and we utilize the service guide delivery unit, which includes a unit header, which has support for versioning of the fragments, and a transport ID, which links it to the delivery mechanisms. And then the actual payload of the SGDU, the service guide delivery unit, is XML fragment. So two other main areas of work in the service announcement and personalization. One relates to the content advisory, and we provide content advisory ratings for different rating regions. And for each rating region, a rating value is provided for one or more rating dimensions. The work on personalization will define data model and the delivery of the personalization data. And the input for that will come to us from TG3 S-34-3, which is finalizing that input. And that currently has two parts. One is related to accessibility and rendering preferences, and the other related to targeting and demographics related personalization. So finally, the other standard that we are working on in 33.2 is service usage reporting. So it's very important to know which services are watched for what duration of time, and additional information regarding the usage statistics. So the service usage reporting working draft currently defines a mechanism where a client can manage the functions of service consumption data collection and storage, and then transmit it back to a server. It is based on ATSC A105 usage reporting, but we did some additional extensions for ATSC 3.0. And those extensions particularly include indication of service usage report per component. So not only can you know that users watched a particular service, but you can know which components of the service were viewed. Indication of delivery path, since we have support for broadcast and broadband as well as hybrid delivery, it can be important information to record and report. Indication of which device the content is being consumed on. And then finally, we are using JSON, which is a delivery format for consumption data messages. So with that, I turn it back to Young. Thank you.
Okay, so this is a final slide. I think I can spend a little bit more time here. So you heard a lot of different things. What maybe complicated to understand everything. But I think this is kind of the slide I like it a little bit highlight that what we are doing as a kind of management and protocol layer is really giving opportunity to the broadcasters to consider ATSC 3.0 as another IP pipe to the whatever device you can reach out. So I think one of the kind of great breakthrough from the communication side between 3G and 4G is 4G becoming kind of the IP pipe. So you don't really care where the data coming from, Ethernet, Wi-Fi, or phone. It just deliver IP, and then the IP connects to your kind of IP-based system, and it's connected to HTML5. So I think above HTML5, that's kind of job of S-34 working on, and then what we are kind of working on in 33 is kind of make sure that you can just plug in your ATSC from a physical layer as another type of IP, so then you can compete with or live together with other IP delivery medium. So then any device you can process above IP can transparently consider physical layer of ATSC 3.0 as a kind of another pipe delivering IP system. So I think that will be kind of very great potential for the case of converting ATSC 3.0 signal to the kind of Wi-Fi signal at home, so then your any portable device capable of IP processing can consume ATSC 3.0 services without adding ugly another stuff on top of it. So we are working hard to make sure that this simplified diagram can be implemented by using our technologies. Okay, that's it.
Questions for Young? Question? Oh, couple.
So we have a basic agreement that word clock will be provided, but we didn't finish the discussion on which type or which format of protocol will be used to deliver that time format yet.
Okay, we're going to stick to these two because we want to keep on track. So Art, I think, Mike was first, I think. Mike and Art.
Hi. When you refer to HTML5, there's the MSC EME debate going on, or standardization, really, going on. Will this standard comply with that whole path? And will all the way through to the EME element?
Yeah, I think that's another good point. We are also considering MSC and ESC as a part of our let's say protocol stack or pipeline, so that if you have a browser supporting file format and MSC, then you can just consume everything. And I think it's a good point that that's also kind of under development in WCC. I think timeline could be another point that we need to consider at the end.
Art.
I'll just try to project.
Okay.
I would suggest that you tweak the slide where you said no MPEG-2TS to make it clear that there's no MPEG-2TS within the IP stack, as contrasted to no support for MPEG-TS with standard.
Yeah, we don't develop things regarding MPEG to TS, but it's there. So if someone wants to deliver it, yeah.
It's not under IP.
Yeah, it's not under IP, but I think definitely there's a way to feed it to physical layer and then deliver it. That's definitely, yeah.
As part of the flexibility, we're not precluding it, we're not especially designing how to do it, but it will be possible, and we can signal its use if one desires to do so. Good point. Thank you.
My concern was you said no use.
Oh.
Right. Okay.
Yep.
Thank you.